So let's discuss about fluid in a rotating container. We all have come through this. So when the fluid rotates or a container rotates, the shape of the fluid looks like this one. Now our prime objective is to calculate how much height is achieved when the container starts rotating, or how much dip here happened when the container starts rotating, because actually it was at this height. Okay, if I name this heights, this was the actual height before the rotation, and after rotation it has achieved two kinds of height. First is y minimum, I am naming them, and second is y maximum. Okay, so our objective is to calculate all these values so that whenever the question is being asked that how much height is achieved, or when it is about to spill from the container, how much height it has achieved. So these are the questions can be asked in the exam, and this is purely point of view of the JEE Advanced. So let's begin with this concept. So to calculate all those things, what we do here, we just take a very small mass in the fluid. Let's say this one. So okay, so this mass is dm and its distance from here is x. This mass is dm and distance from the axis is x. So if we examine the forces which is acting on this mass dm, so I am making that small elemental mass here. So if I say that this force is experiencing, this mass is experiencing a reaction force, so that direction will be like this one. Okay, I am talking about this here. And if I am assuming that this angle is theta, that means this force will have two components, first into this one and another into this one, and due to that theta, this angle is also going to be theta. So this, if this one is r, this is r cos theta, and this is r sin theta. Now the small elemental mass should have some weight, so that weight will be in the downward direction, and this value will be dm into g. Another thing is that since the container is rotating, with that container the fluid is also rotating, so due to that rotation, this mass is I think traversing the circular path. So due to traversing of circular path, it must have centripetal force, and that centrifugal force in fact, and that centrifugal force will act outward. It is dm and the distance is x, dm x omega square. So these are the forces which is acting here, and we resolve all the forces. So if we write down all the force equation, we will have r cos theta is equal to dm into g, and another one which is r sin theta will be equal to dm x omega square. So if we divide these two equations, we will have tan theta is equal to omega square into x by g. Now talking about this mass, so this mass certainly here, the tangent if we draw here, we will get the slope, and that slope will be equal to tan theta, which is dy by dx. So we can write down this as dy by dx is equal to omega square x by g. Further, this dy by dx give us dy is equal to omega square x dx by g, and now we are in the situation to integrate this equation. What we integrate here is if the x was 0, the fluid is at here, which is y minimum. So here y is equal to y minimum, and then when the fluid is at the top, then the the value of y is y maximum. So in that case the x is equal to r. So if we integrate this one, we will have from here is y max minus y min is equal to omega square r square by 2 G. Now one thing is interesting here, whatever the height the liquid goes up, the same height it will go down. So that means we can say that Y naught is equal to Y max plus Y min by 2. So if we calculate Y min from here, we will get Y min is equal to 2Y naught minus Y max. Now here Y naught is the actual height before the rotation of the container. Y min is the minimum height which is achieved by the fluid, and Y max is the maximum height. So from here the value of Y min we will put here, and we will obtain the value of Y max. So it will be plus Y max and minus 2Y naught is equal to omega square R square by 2G. And when we complete this one, we will have this final equation as here is Y max is equal to Y naught plus omega square R square by 4G. So this is the equation which is formed here. So in this way, if the question is being given that there is a container which is having some height and it is having some radius omega, so how much height it will achieve. So let's tackle those questions also by using this simple concept. So this is how we can derive this equation, and that using that equation we can solve the many questions. Let's begin with the questions also. So if the question is asked that if there is a container, okay, if there is a container whose height is 50 meter, okay, radius is 20 meter, and water filled in it is up to 30 meter. Okay, and let's say omega is also given. Omega is equal to 10 radian per second. And the question is asked, calculate maximum height attained by fluid. Calculate the maximum height attained by fluid. So here we have a formula. Okay, now by using the formula we can say that Y naught is given here as 30, R is given here as 20, omega is 10, while G we all know is 10. We have to calculate Y max, so Y max is equal to this value is 30, then omega is 100, radius is 20, here we have 40, omega square is 100, and this is 2, then this will be 50, and from here we will obtain that Y max is equal to 80 meter. So 80 meter means the water is going to spill out this one like this. So in this way this question can be dealt, because the 30 meter height is the water, and water can achieve 80 meter. That means it will spill out from the container and it will go out of this container. So in this way we can solve this problem. This is about this concept. Thank you for watching.